this episode, we step into cloud security fundamentals that sound simple until you realize how many breaches and outages come from misunderstanding them. Cloud service models are the big categories that describe what you are buying when you use cloud, and the shared responsibility idea describes who is responsible for securing which parts. Beginners often think cloud means the provider handles security, but that belief is exactly how blind spots appear. The provider does handle some security, yet you still own many important decisions, and those decisions are where risk often lives. Leaders and practitioners who master these models can ask better questions, design better controls, and avoid the painful surprise of discovering too late that a critical security task was assumed to be someone else's job. The goal here is not to memorize marketing terms, but to build a reliable mental model so you can predict what you must secure, what the provider secures, and where responsibility overlaps. When you can do that, you can plan identity controls, network boundaries, logging, and configuration discipline with clarity instead of confusion. A useful starting point is to separate the cloud from the internet, because beginners often treat them as the same thing. The cloud is not simply a website or a remote server. It is a way of consuming computing resources as services that are delivered through APIs, automation, and large-scale infrastructure. Cloud providers run massive data centers, but the key difference is that customers rent capabilities on demand, and those capabilities can be created, changed, and destroyed quickly. That speed is both an advantage and a risk, because mistakes can be repeated at scale. Cloud also shifts work from buying and maintaining hardware to managing configuration, identity, and data. Beginners should notice that this shift does not remove responsibility. It moves responsibility into places that are less visible than a physical server room. Instead of worrying about a stolen hard drive, you might worry about a misconfigured storage service that exposes data publicly. Instead of worrying about a locked data center door, you might worry about an overly broad permission that lets a user create risky resources. Cloud security is therefore a discipline of understanding service boundaries and controlling how those services are used. The service model you choose determines which boundaries exist and where you must focus your controls. The three classic cloud service models are infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS, and each one represents a different division of labor. IaaS is the most flexible and the closest to traditional servers because the provider offers raw computing building blocks like virtual machines, networks, and storage, while the customer configures the operating system and the software stack. PaaS provides a higher-level platform for building and running applications, which means the provider manages more of the underlying environment and the customer focuses on the application and data. SaaS is an application delivered as a service, where the provider runs the app and the customer mainly manages how it is used, such as user access, configuration, and data. Beginners should notice that as you move from IaaS to PaaS to SaaS, the provider manages more layers and you manage fewer layers. However, you never manage zero layers because you always manage something like identity, data, and usage policy. The model you choose changes what you can control and what you must trust. Understanding that trade-off is the first step toward avoiding blind spots. Infrastructure as a service is often chosen because it offers control and compatibility, especially when organizations want to run custom software or migrate existing systems. With IaaS, the provider typically secures the physical data center, the hardware, and the virtualization layer, while the customer secures the operating system, applications, configurations, and access. Beginners should understand that this means many traditional security tasks still exist, like patching the operating system, hardening services, and managing network exposure, even if you are not racking servers yourself. A common blind spot is assuming the provider patches everything, when in IaaS the customer often owns patching and configuration of the virtual machine and its software. Another blind spot is assuming the network is safe because it is in the cloud, when in reality misconfigured network rules can expose services publicly. IaaS also gives the customer more responsibility for monitoring, because while the provider may offer logging capabilities, the customer must decide what to collect and how to respond. The benefit of IaaS is flexibility, but the security cost is that you are responsible for more layers, and more layers means more opportunities for misconfiguration. If you choose IaaS, you need disciplined operational practices because security is heavily dependent on how you configure and maintain what you build. Platform as a service shifts more responsibility to the provider, and it is often chosen to speed development and reduce operational overhead. In PaaS, the provider runs the platform, which might include managed runtimes, managed databases, or managed deployment environments. The customer still owns application code, data, and access decisions, but the provider handles many infrastructure concerns such as patching certain platform components and managing underlying scaling. Beginners should notice that this can reduce risk in some areas, because fewer customer-managed layers means fewer opportunities to forget patching or to misconfigure low-level services. At the same time, PaaS introduces new security concerns around configuration and data handling, because the platform often offers many options and unsafe options can still be chosen. Another blind spot is assuming PaaS means the application is secure by default, when in reality application-level vulnerabilities, authorization mistakes, and insecure data handling remain the customer's responsibility. PaaS also changes monitoring and logging, because the platform may abstract away details that an investigator would want, which means customers must plan what visibility they need and how to obtain it. The key governance question becomes whether the team understands what the platform does for them and what it does not. PaaS can be a security win when used well, but it requires careful understanding of the shared responsibilities at the platform boundary. Software as a service pushes the provider's responsibility even higher, because the provider runs the application, manages the environment, and often controls updates and infrastructure decisions. Customers usually configure the application, manage user identities and permissions, and control what data is stored in the service. Beginners should recognize that SaaS does not remove security responsibility, because the most common SaaS failures come from mismanaged access, weak account security, or poor configuration choices. Another blind spot is assuming the provider's security posture automatically fits your organization's needs, when in reality you must evaluate whether the provider offers the controls you require, such as strong authentication options, logging, and configuration features. SaaS also creates a dependency on the provider for patching and vulnerability management, which can be a benefit because the provider can update quickly, but it also means customers must trust the provider's transparency and incident response. Customers are still responsible for what data they place in the service and for how they grant access to it, which includes least privilege and lifecycle management for accounts. Another hidden risk is integration, because SaaS tools are often connected to other systems, and those integrations can become pathways for data leakage or unauthorized actions. Mastering SaaS security therefore means mastering identity, configuration, and vendor governance, not managing servers. The shared responsibility concept is best understood as a layered stack where different parties own different layers, and the division depends on the service model. The provider typically owns physical security, hardware, and core infrastructure protection across all models, because those layers are part of the provider's platform. The customer owns what they put into the cloud, such as data, identities, access policies, and configuration choices, because those are unique to the customer's needs. The boundary changes across IaaS, PaaS, and SaaS, but the key is that the boundary always exists and blind spots appear where people do not clearly define it. Beginners often assume shared responsibility means shared blame, but in practice it is shared work, and the goal is to define it so there is no ambiguity. If something goes wrong, the first question should be which layer was involved and who owned that layer. This mindset prevents the unproductive reaction of blaming the cloud while ignoring misconfiguration or poor access control. It also prevents the opposite mistake of blaming customers for provider failures that are truly provider-owned. Clear responsibility mapping is a governance tool because it turns cloud security into specific tasks rather than vague anxiety. One of the most important responsibilities customers always retain is identity and access management, because access is how work gets done and also how attackers get in. Even in SaaS, where the provider runs the application, the customer typically controls who can log in and what they can do once they are in. Beginners should understand that weak account security, such as missing strong authentication, can defeat all other protections. In IaaS and PaaS, identity is also tied to administrative control over cloud resources, which means the identity system can grant power to create, change, or delete infrastructure. This is why cloud security is often described as identity first. If identities are overprivileged or poorly protected, attackers can operate with legitimate-looking access. Shared responsibility does not mean the provider manages your identities. It means the provider provides identity features, and you choose how to use them. A common blind spot is treating identity as an IT detail instead of as a primary security control. When you master shared responsibility, you recognize identity as your responsibility across all models, and you treat it with the same discipline you would treat physical keys to critical systems. Another customer responsibility that persists across models is data security, including classification, protection, and lifecycle management. Cloud providers can offer encryption options and secure storage designs, but customers decide what data is stored, who can access it, and how long it is retained. Beginners should notice that many cloud incidents involve data exposure through misconfiguration, not through a provider breach. For example, if a storage service is configured to allow public access, the provider did not leak your data, your configuration exposed it. This does not mean cloud is unsafe. It means configuration discipline is essential. Data responsibility also includes understanding where data flows, especially when services integrate with each other. In SaaS, data can move through integrations to other tools, which creates new exposure paths. Leaders must ask where sensitive data is allowed to go and how those boundaries are enforced. Shared responsibility means the provider offers features, but you must use them correctly to protect your specific data. When you treat data security as your own responsibility, you reduce the chance that cloud convenience becomes cloud exposure. Visibility and logging are another area where blind spots appear because people assume the provider will tell them what happened when something goes wrong. Providers typically offer logging capabilities, but customers must enable them, choose what sources to collect, decide retention, and build alerting and response processes. Beginners should understand that if you do not collect logs, you cannot investigate incidents effectively, and you may not even know an incident occurred. In IaaS, you may need visibility into operating system events and network activity, which are often customer managed. In PaaS, the platform may abstract certain details, so you must know what logs are available and how they map to your detection needs. In SaaS, the provider may offer audit logs of user actions, but customers must review them and integrate them into their broader monitoring. A common blind spot is assuming default logging is sufficient when defaults are often minimal. Another blind spot is collecting logs but not monitoring them, which creates a false sense of security. Shared responsibility means the provider provides the capability, but you provide the operational discipline. Mastering this area requires planning for visibility from the beginning, not after the first incident. Configuration management is also central to shared responsibility because cloud security is heavily determined by how services are configured. Providers build secure platforms, but they often allow customers to choose less secure options for flexibility, which means customers must make wise configuration choices. Beginners should notice that cloud risk is frequently a risk of convenience, where a setting that makes access easy also makes exposure easier. This is why organizations use reviews, policy gates, and guardrails for cloud configuration, because the goal is to prevent unsafe states from being created repeatedly. In IaaS, configuration includes network exposure and operating system settings. In PaaS, configuration includes service options and access policies. In SaaS, configuration includes features, sharing settings, and integration permissions. The model changes the configuration surface, but it does not eliminate it. Leaders must ensure that ownership for configuration is clear and that teams have standards for safe defaults. Another blind spot is assuming that because a service is managed, it is configured safely, when in reality a managed service can still be exposed if the customer chooses unsafe settings. Shared responsibility means you must govern configuration choices intentionally. Vendor responsibility, customer responsibility, and shared responsibility also intersect in the area of incident response, and beginners should understand that cloud changes the nature of coordination during incidents. Providers may detect and respond to issues in their infrastructure, but customers must detect and respond to issues in their accounts, configurations, and data. In SaaS, the provider may handle patching and infrastructure recovery, but the customer still needs to manage compromised accounts, suspicious user actions, and data exposure events. In IaaS, the customer must often handle containment actions at the operating system and network level, while the provider ensures the underlying platform remains stable. A blind spot appears when organizations assume the provider will notify them of everything, because provider notifications typically focus on provider-owned issues, not customer-specific misuse. Another blind spot appears when organizations do not have clear procedures for contacting providers, collecting evidence, and understanding what logs are available. Shared responsibility requires pre-planning, including knowing what support channels exist, what service-level expectations apply, and what the organization will do internally when an event occurs. When you master shared responsibility, incident response planning includes cloud coordination as a normal part of readiness. When you step back, mastering cloud service models and shared responsibility is about removing ambiguity so security tasks are assigned, resourced, and verified. IaaS provides flexibility, but leaves customers responsible for many layers, including operating systems and application stack security. PaaS reduces some operational burden, but still requires strong application security, careful configuration, and thoughtful visibility planning. SaaS shifts much of the infrastructure management to the provider, but customers still own identity, configuration, and data governance, and those are where many failures occur. Across all models, shared responsibility is not a slogan. It is a practical mapping of layers to owners, with identity, data, configuration, and monitoring remaining critical customer responsibilities. Blind spots appear when teams assume the provider handles what the customer actually owns, or when teams ignore how integrations and configurations expand exposure. For a beginner, the most important takeaway is that cloud security starts with knowing exactly what you are consuming as a service and exactly what you must secure yourself. When you can name the model, locate the boundary, and assign responsibility without hesitation, you are far less likely to miss a control that matters and far more likely to build cloud systems that are both flexible and safely governed.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.